Welcome to day number 9, our second last video of this AIM program. So today is about rearranging formulas. This is an expansion or kind of the second part of what we started in the previous video about manipulating equations and how to kind of move things from one side of an equation to the other. And then we use that to talk about how to solve single variable equations. And today we will be doing that with equations with multiple variables. Often, for example, things like formulas where we don't have all the numbers. We can't say, oh, this variable is equal to this number. We just rearrange it in terms of some other variables. All right, so getting into it here, the thing to talk about just before that is to remind you of this, the order of operations. So if we have an equation with a whole bunch of stuff in it, well, which part comes first, which part comes second, which operation do we do first? Well, this way. So I know, I'm sure in each of your languages and countries, you have your own thing or way of remembering this. This is the way it's talked about in English. A few different ways. When I was a child growing up, I learned this one, BEDMAS, B-E-D-M-A-S, for brackets, and then exponents, division, multiplication, addition, and subtraction. The British style, which I prefer the term parentheses here, so is PEDMAS, so parentheses first and then exponents, and then division and multiplication together in the order that they appear, and addition and subtraction together in the order that they appear. You might have also maybe seen this one, PID. Sometimes some British textbooks, instead of exponents, they would write these as indices, which is the same basic thing here. So different labels, but it's all the same thing. Brackets first, and then the exponents, then dividing and multiplying, and then adding and subtracting. So we're going to use this to help us with the process here. We'll start off with some really simple things. Formulas for converting between temperatures, between Fahrenheit or Celsius here and Fahrenheit here. So this question is asking us to solve for F. So it does say solve, but we will not be able to get a number just like F equals this because we have another variable here. So it will be in terms of C. Our solution here will be F equals something, 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 C something, something, something. What that is, well, we'll see. But for now, we just know that the goal is to have F on one side of the equation and everything else on the other side. So three different ways that we can do this, as I mentioned. First, we'll talk about that PEDMAS order, P-E-D-M-A-S. So if we look at F here and imagine we did have a number for F, and if we were to evaluate this, we'd look at our order of operations here. In this equation, so this subtraction is happening first because it's inside these brackets. And then second, we have, well, this division here with this fraction, and underline that. And then we would have this multiplication between the fraction and the brackets here. So let's say that's number 1, that's number 2, and that there is number 3. So to rearrange in terms of f, we would just take this and we work in reverse order, opposite order from whatever our order of operations is. So to do that, so the 2 here, 5 divided by 9, we don't actually have to evaluate that. That's sort of a freebie. We can pay attention just to the parts that are impacting our f here. Let's just rewrite this a bit. Say, number 2. Okay, so our first line here, C, and we want the 5/9 to be to the other side, so we need to do the opposite operation. We have 5/9 times f minus 32, so we should do the opposite operation. We should be dividing by 5/9, 5/9 times f minus 32. I'm going to erase this and just do the color coding a little better for clarity here. 5/9 and dividing by 5/9/9. So we're doing the same operation on both sides. That's how everything stays balanced. That's what we talked about in the previous video. And we have 5/9 times this thing in brackets. So now we're doing the opposite operation to kind of get rid of it. We could also think of this as multiplying by 9/5, the reciprocal or the inverse of the fraction. But also dividing by fractions, that's what you do anyway. So let's do that. So this would turn into C times 9/5 and 5/9 times f minus 32 and times 9/5. All right, so the 5/9 and the 9/5 do cancel each other out. It's 2 multiplication operations here, 1 on each side of the brackets, and we can just rearrange the order. That's fine. So the 5 and the 5 cancel out, the 9 and the 5. So on the left, we are left with just f minus 32, and on the right here, f minus 32, and on the left, c times 9/5. Okay, so that was operation number 2, sort of done. And now we'll do the same thing and get rid of this 32 here. This is our other operation. So this minus 32, we're going to do the opposite and just add 32 to both sides. Let's just a little bit of space here. E times 9/5, and then like this, plus 32 and plus 32. Okay, and then on the right side here, we have just f, and on the left side, we will have c times 9/5 plus 32. We're done, because we have f sort of alone or isolated here, but let's just rewrite a little bit because this looks really bad. Normally, we would have the thing we're solving for on the left side, so f on the left side, and c times 9/5, let's just rearrange that to have our constant at the coefficient at the front here. So 9/5 times c plus 32, like this. Okay, so there we go. We have solved for f. Lots of extra detail there. We can obviously do this more quickly, but just want to be very clear on what that process is. So we have our order of operations, our standard order of operations. You're just going to work in reverse from that, kind of go from the outside all the way to the inside. Let's look at another example with the thing that we just found, let's go backward, but I've erased what we did, so let's just figure it out again here. So we want to solve for c. So we want c isolated, c equals something, and we know there will be an f because we can't get rid of that f. We don't know a number for it there. All right, so the first operation we have is this 9/5 times c, this little multiplication here. That's operation number 1. And then after we are adding 32, so that's operation number 2. So we're going to go in the reverse order. So f, and we will subtract 32 from both sides. Minus 32 equals 5 times c, and plus 32. And of course that simplifies to f minus 32 and 9/5 times c. So now the 9/5 times c, we want to get rid of that, so we are going to divide both sides. Divide by over 5. It's a little sloppy there. Apologies for that. And we will divide on the other side here by 9/5. And when we simplify this on this side here, on the right, we will be left with just c. And on the other side here, let's just put the 9/5 kind of in front. Standard way of writing it. 9/5. Sorry, not 9/5. We are dividing by a fraction. So that means that's the same as multiplying by the inverse of that fraction. So we flip over and multiply. So that's the same as just multiplying by 5/9. So that times f minus 32. Okay, and let's just clean this up, rewrite it. This with our c on the left side, c equals 5/9 times 2. Okay, so that is what we started with in the previous example. So we've gone in both directions and sort of shown that we are able to do that. All right, so that's an original example and a practice for me. And now your turn with this one. With this one. So different fraction, or sorry, different formula here. And we want to solve for a lowercase b. So lowercase b equals something. So take some time and try to figure that out. All right, our solution here, hopefully what you got is this. Lowercase b here is equal to 2ah minus capital B. Should be the result of you rearranging this. What is A? What is H? What is uppercase B or lowercase b? Doesn't matter. It's a formula for something, but we don't need to know that to be able to rearrange it. Okay, so there's our solution there. Let's look at another set of examples using a different technique here. Kind of the same thing really, but thinking about it a different way, but just brackets. So let's say in this one, we are asked to solve for h. So h equals something again. So we have this h, and let's just put brackets around the h and sort of in steps in terms of what is closest to this h. H times what, or divided by what, or plus what, or whatever. So the closest operation to h is this times r here. Let's put, yeah, let's do the original. Okay, so there's our h, and then brackets around this r here. And then we have brackets around this pi times r times h, and 2 times pi times r times h. That looks pretty messy. They're all just multiplication. So it's really the same thing. So I'm just going to say, let's get rid of these ones here. And just think of it this way. So here's our h, our core thing. And then the closest thing to it is when it's multiplied by this 2 pi r. And then next after that is adding this addition operation with this outer stuff here. So adding all the other stuff to it. All right, so if we do it that way, then again, it's the reverse order of operations still, but we're just thinking about it a different way, sort of thinking about it from the outside brackets towards the inside brackets. So outside brackets we have here. So if I have this positive 2 pi r squared, then I need to just subtract that from both sides. So our first line here would be s minus 2 pi r squared equals 2 pi r squared plus 2 pi r h minus 2 pi r. And we can keep these brackets in here if that helps us. Just kind of keep everything organized. But the addition is sort of happening on the outside. Addition, subtraction, we can move those around, change out the order. Sorry, I wrote 2, that is the wrong thing. Not pi r h, this should be 2 pi r squared, same as this term here. Okay, so we do that. Those will cancel out, they're gone. Our next step then is that we have this s minus 2 pi r squared equals 2 pi r h. And the next brackets that we had here, we did have extra brackets around our h. Okay, so we'll now do the next sort of inner set of brackets here, and 2 pi r. 2 pi r is the problem. We want to get rid of that. So we will just divide both sides by 2 pi r. Let's write it sort of like a fraction. So divide this side by 2 pi r and divide the other side by 2 pi r. And then on the left side, everything's going to cancel out except the h. And on the other side, it's just as it is. Nothing really gets simplified there. 2 pi r, yes, that's right. So s minus 2 pi r squared over 2 pi r. And if we want to, again, make this look a little nicer, put our h on the left side, we can do that. H equals s minus 2 pi r squared, ugly looking pi r squared over 2 pi r. And we rearranged. So now we have h, we have solved for h in this formula, and if by chance we knew all of the other numbers, the s and the r, and we had to figure out h, now we can easily do it because we've successfully rearranged the formula. All right, so that's a longer example, just brackets and then outer brackets and then more brackets to help you kind of see what the order of operations is and then work from the outer brackets towards the inner brackets. So let's do a practice with that. And this one here, a equals p plus prt, and we are solving for t, it's asking. So here's our t, and then this times pr, and then plus p here. That's our order. So first line here, it will be a minus p equals prt. And then the next line, we're just dividing by pr. Put those brackets back in here like this. Dividing by pr, so a minus p over pr equals t, and we're done. Okay, so that's my practice, my turn, and your turn with this one, solving for r. So it's the same formula here, but solving for a different thing. Go ahead. All right, our solution to this one is almost the same as what we had in the last one. A minus p over, but pt equals r, like this. The t and the r switch places compared to the previous solution. Okay, that's that one. Last technique that I will show you. So far we've done our bedmas or pedmas in reverse order, and we've just drawn a bunch of brackets and then worked from the outside towards the inside, which is the same thing. The last one will be sort of pretending that we have numbers. So here we are asked to solve for y. 8x plus 7y equals 15, and solve for y. So y equals something. Make sure I'm still, yep, okay. All right, so the thing that we can do here is look at each variable that is not our target variable and just swap it out for some number. So instead of x here, let's pretend it's, we don't know this, but let's just pretend x is equal to 2. If that's the case, then we would have here, our next line here would be 8 times 2 plus 7y equals 15. And if I gave you this and I asked you, tell me what y equals, you could probably do it and it wouldn't be that hard here. The one thing about this technique is do this, but don't actually evaluate the things here. Like, don't actually do 8 times 2 and then that's 16. So don't do that. Just leave the two numbers separate and just kind of move them as a group. So if what we would do here is we would just subtract 16 from both sides, right? Or subtract 8 minus 2 from both sides. So if we did that, we would have 7y on this side, and then on the other side we would have 15 minus 8 times 2. And then we would have the 7, which we don't want. We want to get rid of the 7, move it to the other side. So we would divide both sides by 7. Y equals 15 minus 8 times 2 all over 7, like this. And we could split that up and whatever, but that does achieve the basic goal of having, excuse me, of having the y isolated here. So we did that, and if it's all numbers except for our target variable, it's probably easier to think about and just intuitively you can solve it. So we can do it that way, and then now bring back the variables and do the exact same process. That can just kind of help us see our way through certain like harder steps here. So what we actually have is 8 times x plus 7y equals 15. But I'm going to do the same thing that we did on the other side. First thing that we did, we took the 8 times 2 and we just subtracted that from both sides, and that moved it over to the right. So that means that our next line here would be 7y equals 15 minus 8 times x, which I'll just write as 8x, our normal way. So that's the first step. We just kind of model exactly what we did on the other side when we pretended we had numbers and values. And then we do the same thing with the variable version of things. Okay, and then next we'll just divide both sides by 7 like we did. Y equals 15 minus 8x over 7. So we are done at this point, but you are probably recognize that this thing here, the original, kind of looks like the equation of a line in standard form. And then we probably want to rearrange it to be sort of in this y equals mx plus b form. So just in case that's the situation, let's take a look at how we would do that. First, we'll split up the right side here into 2 parts, 2 fractions. So y equals 15 minus 7. I'm not sure if you heard that, but that was my phone beeping. Got to mute it before I started. There we go. Okay, so that's that. But we want the x part to be first, so we'll just rewrite this as negative 8 over 7x, and then plus 15 over 7. So there's our sort of mx plus b format here. But again, this version is done because we have solved for y technically. Okay, so replace all of your non-target variables with with numbers, just like 2 or 3 or some easy numbers, and then rearrange, but don't actually evaluate. Just leave those numbers separate. Don't actually add them or multiply them to something. Don't combine them with other numbers. Keep them separate. Just move them back and forth. And this will just kind of help you, again, see your way through a more complex step, if there is one in the question. All right, let's do another example. These are all the same basic type here. So again, we have this sort of standard form, this 4x plus 7y equals 9, and I want y to be alone here. So let's say we are going to do, again, let's do our step of pretending that we are writing it separately. So 4 times, let's say, I don't know, 3. Pretend that x is equal to 3. 4 times 3 plus 7y equals 9, so 7y. If I had 4 times 3 or just 12, I would just subtract from both sides. So 9 minus 4 times 3, and then we'd subtract divide to move the 7 over to the other side. 9 over 7. Write it this way. 9 minus 4 times 3 all over 7. And then if we do this with our variable version, where our x is just x, we don't know what it is, so we can't change it out for anything, then 4x plus 7y equals 9, and we will just subtract the 4x from both sides. 7y equals 9 minus 4x, and divide by 7. Y equals 9 minus 4x over 7. Y equals 9 over 7 minus 4 over 7x, and I'm going to put the x in front. Negative 4 over 7x plus 9 over 7. There. Okay, so again, if you stopped at this stage here, that is fine, but if we are dealing with lines and linear equations, then very useful to have that final version there. All right, one more here for you to do, and then we will move on to our final sets. So do this practice one here, and then we'll go to the last part. All right, our solution here is, let's write this out. So kind of in two versions of this answer. So first, y equals, let me just put this out in my head myself, 1 minus 5x over 8, this, but then if we kind of rearrange it to the y equals mx plus b form that we did for the previous questions, it would end up being negative 5 over 8x plus 1 over 8, like this. So two different ways we might have expressed our answer. Right, okay, so that is 3 different methods. Do your order of operations, PEDMIS, BEDMIS, whatever, in reverse order, or write a whole bunch of fractions. Sorry, write a whole bunch of brackets, sort of inner brackets, outer, and then work from the outside in. And the third method is pretend that you have a number instead of a variable for all of your kind of non-target variables, and then just intuitively, hopefully you kind of see what the process is. All of those things can help us. So let's do that here, and I've written out the steps, just the 3 different suggestions here that we could use. So this is the question that I showed you at the beginning of the previous video. We have this long thing here, and we are being asked to solve for C. Okay, so I'm going to do the brackets method. We have brackets here, and then next is we are dividing by E, and then finally we are adding F. So let's go from the outside, work in here. So first step here, we will, I'm not going to write the minus F on both sides. I'll just kind of skip that part to save us some space here. So A plus B, let's just do it color, kind of C minus F. So C minus D divided by E. Okay, so we did that part. So we still have these kind of second outer brackets here to deal with. So dividing by E, then we multiply by E to get rid of that and move that over to the left side. So E times everything that was on the left, A plus B minus F equals C minus D. And actually, we don't need these brackets anymore. The final, well, okay, I'll write them in red here. So now we have the final set of brackets on with that's connected to C or impacting C, and so C minus D, we just add D to move that over. So our final thing on the left here will be E times A plus B minus F plus D, and that's equal to C here. Okay, so we'll rearrange, put our C on the left side, E, A, B, E, F plus E. There we have rearranged for C. So again, if this is a formula and we know what E and A and B and F and D are, then we can calculate what C will be. So if this kind of question is confusing for you, just hopefully kind of the moving things from one side to the other side, how to do that is not that confusing. It's just sort of when or what things go first. So writing out these brackets or imagining your variables as numbers or doing your reverse order of operations, all of those are useful techniques here. I've just done the brackets version, just so we're not here in this video forever. I won't repeat the question with the other types. But I'll do, I guess, well, I can do that with the next example here. Actually, well, maybe not. This one's pretty simple. Not enough here. So exact same original thing, but we're trying to solve for B. This one's actually pretty easy. So all the stuff on the left, sorry, on the right, it's already isolated from B. We don't have to do anything. We don't have to touch that. The only thing that we have is this A plus B here. So we just move the A to the right and we're done. So E equals C minus D divided by E plus F. And I'm just going to subtract A from both sides. Color minus A. And that's it. That's solved. There's B isolated. That one was pretty easy. The other one for you to try is not going to be quite as easy. So same original formula, but try to solve for E. Try to isolate E. Go ahead. All right, let's take a look. I'm going to actually write out the solution fully for this one, unlike our previous examples. So on the right side where our E is, we do have these inner brackets with the C minus D. We don't care about that part because the whole, we can just move that as a unit. So what we do care about is this division here. So C minus D as a block, as a whole, is being divided by E. So that division is the problem there, or is the thing we're going to have to focus on. And then outside of that, we have this plus F. So the plus F we can do pretty easily first. So A plus B and just subtract F from both sides, minus F equals C minus D divided by E. Okay. So few different things we can do here. Let's rewrite this as a fraction just to help us think about this. So c minus d over e. And we want e to be isolated. So we can't just move the c minus d over. Well, we kind of can. There's a few different ways of thinking about this. But let's just do kind of our most typical standard way. We have this thing. We want to get rid of it. So we are just going to divide by that. And that will get rid of it. So we will multiply by basically 1 over c minus d, like this. And then on the other side as well, we are multiplying by that 1 over c minus. Okay, so then on the right side, just to convince you that yes, this does actually work. So c minus d on the top here, and on the bottom e times c minus d. And then we have c minus d on the top and the bottom. So again, just look at them as a unit. Together, they cancel each other out. It doesn't matter what c and d are. So this and this will cancel out. And then on the right side, sorry, on the left side, we will have a plus b minus f over c minus d, like this. Okay, so simplifying here, we will have 1 over e and a plus b minus f over c minus d. Okay, well, we're almost there, but we have 1 over e and we don't want that. We just want e. So what we can do here is a few different things, a few different ways of thinking about this. But if we just invert, we take both sides and we just flip them over, flip them upside down, which we can do with an exponent. So exponent -1 is the formal way of doing this, but just flipping over the fractions on both sides. That's always possible. So if we do that, we will end up with c minus d over a plus b minus f, and then just e on the other side here. Just for sake of thoroughness, in case that was confusing for you, if you want a different way of thinking about this, when we are at this stage, a plus b minus f equals c minus d over e. Another way of thinking about it, it will give us the same result, is just to multiply both sides by e, like this. So that would give us e times a plus b, a times e times a plus b minus f. And then on the right side here, we would just have c minus d. So that might look like it didn't really help us, but then we can just easily divide both sides by this thing. So divide both sides by this a plus b minus f. Again, it's a unit, so as a whole, it will cancel out with the other one on top. And a plus b minus f here. And then that leaves us on the left side with just e, and then on the right side with c minus d over a plus b minus f. So same result that we had on the other side, just different ways of thinking about it. And there are more too, but hopefully that's enough to see what's happening here. So 3 different methods. Again, reverse order of operations, or write in a bunch of brackets and do them from the outside in, or replace all of your variables with numbers and then see how you would do it, and then do exactly that process with the variables. Excuse me. Okay, so that's that one. I'll show you some practice questions. Just in chapter 2.3 here. So rearranging formula, there's a bunch of practice of this in our intermediate algebra textbook. Those ones there, exercises 165 to 194. So take some time with that. This is a really essential skill. Instead of having to like memorize 4 or 5 different versions of a formula, if you can just remember one of them and then know how to rearrange and move the parts around, that's much more powerful, much more useful in math. So I will encourage you to practice this stuff and make sure you're comfortable with it. And that's it. So that's all we did today, basically rearranging formulas or equations with multiple variables in them. And in our last video tomorrow, we will talk about function notation, what that is and how to think about it. Okay, so thank you for watching today, and I will see you in our last video tomorrow.